Number 18, 1 over 6 to the negative 4. This tells me take my base that's in the denominator, 6, change it to in the numerator and make the exponent positive. So 6 to the 4th, 6 times 6 is 36 times 6 is 216. Let's see if I can get my calculator out here. That's going to be 1,296. So this one can be a little tricky. 19. Now remember, the negative exponent means you're going to take the reciprocal. So I'm just going to take the reciprocal. Well, that's going to be negative 3 over 1. It just means flip it and change it to a positive exponent. So that's negative 3 over 1, which is just negative 3 to the 5th. And that means I'm going to multiply negative 3 5 times. And notice that that it's going to be a negative, right? Because you've got negative 3 5 times. You have an odd number of negatives. And that's going to be a negative. And then 3 to the 5th is 243. So it's negative 243. Now, there are a couple of ways to do number 20. One is to apply the quotient rule. It says the top and the bottom of a quotient both get the exponent. And then change these bases to the opposite part of the fraction, or just flip the guy over from 5/6 to 6/5 and raise it to the third, and you get the same answer. 6 to the third over 5 to the third is 216 over 125. A negative exponent means reciprocal. That's all it means. Flip it over. It means take the reciprocal of the base. Remember reciprocal when you're doing fractions before? That if you have A over B, then the reciprocal is B over A. You just flip it over. Now this one, number 21, 2 to the negative 1 plus 6 to the negative 1 is a little tricky because you got to do each one first. 1 over 2 plus 1 over 6. But to add fractions, you have to get a common denominator. And these will both go into 6. So I'm going to have to multiply my first fraction, top and bottom, by 3. That's going to be 3 over 6 plus 1 over 6 is 4 over 6, which is 2/3. Simplify the expression. Well, let's do what's on the top first. X to the 9th over X to the 4th. And that means I subtract, so my answer is X to the 5th. Number 23. A couple of ways I can do this. I'm going to apply my outer exponent to both things inside by multiplying power to a power. So it's x to the negative 24, y to the negative 24, and I have to take the reciprocal of both of those, so they have to go to the denominator, x to the 24, y to the 24 in the denominator. Number 24, the 9 will go into the 18 and leave a 2, so that gives me a negative 2. I've got a to the 6, or 6 a's multiplied in the top, but only 1 in the bottom. That's going to give me an a to the 5th in the top. I have a single b in the top, but 7 b's in the denominator, so that's going to give me b to the 6th in the denominator. Remember, if you've got a to the 6th in the top and a single a in the bottom, well, that one a from top and bottom will divide out and leave a to the 5th. But if you've got a single b in the top and 7 b's in the bottom, one of the b's will reduce out and the 6 b's will be left in the denominator. I'm going to apply the power to a power rule. I'm going to multiply a to the negative 7 to the negative 5 is a to the 35. B to the 4th to the negative 5 is b to the negative 20. But I don't want to leave a negative exponent, so the b to the 20 is going to the denominator. So a to the 35 over b to the 20. Number 26. I've got a 7 and a negative 4. Well, that's just going to be a negative 7 over 4. And it's best not to have the negative in the denominator. It's best to put it in the top or even with the bar. X to the 7th over x to the 6th is going to leave an x in the top, right? Because I got 7 x's in the top and 6 in the bottom. These all divide to 1, and that leaves a single x in the top. But look, I've got 7 in the bottom, but 2 in the top. That's going to leave a y to the 5th in the bottom. I subtract y to the 2 minus 7 is y to the minus 5, but because it's negative, it ends up in the denominator. So that one is negative 7x over 4y to the 5th. And number 27. I would reduce everything inside first that I can. So 5 into 15 is going to give me a 3. This a to the negative 7, I'm going to move it to the top, a to the 7. So far I have a 3, a to the 10th, because look, a to the 3rd and a to the 7th is a to the 10th. And look, b to the 3rd is going to leave me b to the 3rd in the bottom because 6 b's in the denominator multiplied and 3 in the top. So those will divide out and leave the 3 in the bottom. So I have that. Now, I still have to apply that negative 2. So I've got 3a to the 10th over b to the 3rd to the negative 2. So that's 3 to the negative 2, a to the negative 20, because power to a power I multiply, over b to the negative 6. All of those are going to change. The 3 to the negative 2 is going to become 9 in the denominator, right? Because 3 squared is going to the denominator. B to the 6 is going to the numerator. And a to the negative 20 is going to be a to the 20th in the denominator. So it's b to the 6th over 9a to the 20th. And last thing, let's talk about scientific notation. Scientific notation is used to abbreviate very large or very small numbers. When you're working with science, sometimes you're working with really big numbers, like how many miles is it to a planet, or in microsurgery, how many millimeters is it, the size of this thing that you need to extract during surgery. So it could be a very small or a very big number. So a very big number might be something like 6 trillion. And a very small number might be like something like let's see, that's tenths. Let me count these. Let's see, that's tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions, 10 millions, 100 millionths, 145 100 millionths. So 145 out of 100 million. Very, very tiny. In scientific notation, the format is some number times 10 to some power, and the number has to be between 1 but less than 10. So it can be 1, but it can't be 10. So that's why the equal sign is here, but not on this end. So 6 what do we say, 6 trillion would be 6 times 10, and I moved my decimal from the second position to the end. That's 12 places. Big number, positive exponent. Okay, this means that I would have to multiply by 10 12 times, and every time I multiply by 10, it'd be one place to the right when you multiply by 10. And this one's going to be a negative exponent. It's going to be 1.45, because remember, it has to be between 1 and 10, so you go behind the first non-zero number. And this time, it's going to be a negative exponent. It's going to be, from here to here, I count 1, 2, 3, 4, 5, 6, negative 6. That means I divide by 10, and every time I divide by 10, it moves it one place to the left. So remember, big number, positive exponent. Little number, negative exponent. 84,000. Well, I go behind the first number, 8. 8.4. Now, that's a big number, 84,000 times 10 to the 4th, because between there and the end is 4 places. Little number, go behind the first non-zero number, 1.43 times 10 to the negative, because it's a tiny number, 1, 2, 3, 4, 5, 6, 10 to the negative 6. Tiny number, 7.08 times 10 to the negative 3, because I went right behind the 7. 1,950,000, big number. 1.95, and you can put the zeros, but you don't have to. But you do have to count them. Big number, positive 6. Now we're going in the reverse order. If it's a negative exponent, we're dividing by 10. It's going to the left 7 places, so I need 6 zeros. 1, 2, 3, 4, 5, 6, 9, 4, 1, 1. This means, remember, 9.411 over 10 to the 7th. That means 9.411 divided by that. 1, 2, 3, 4, 5, 6, 7. You do it on your calculator, you get this tiny number. But really, just move your decimal to the left if it's a negative. Same thing here. I've got a negative exponent. I'm moving it back 3 places. 0.0071. Here, positive exponent. I'm moving it to the right. 3083. 3083. Negative number, negative exponent, small number. Positive exponent, large number. Last problem. Each second, a star converts 5.0 times 10 to the 9 tons of hydrogen into helium and energy in the form of gamma rays. Write it in standard notation. Now remember, what I said was this is usually used in science, so you can tell this is a science application. Well, what does that mean? It means we need to move it, the decimal point, to the right 9 places. So I need to put 9 zeros. 2, 3, 4, 5, 6, 7, 8, 9. And so I've got 3 sets of zeros. That's going to be the third choice. So it's 5 billion. Remember, because this is millions, and this would be billions. So 5 billion.